What's up, everybody? This is Daniel Mathematics here with another example to explore. And today, guys, I want to go over word problems dealing with percents, right? Word problem dealing with percents. And remember, guys, percents fall under the proportionality umbrella, along with ratios, unit rates, measurement conversions, scale factoring, so forth and so on, right? And remember, guys, in order to solve, to find out the unknown value, we're going to use the box method in order to do so, right? We're going to use the box method. And while using the box method, guys, you can either cross multiply to find out the unknown value, or you can use scale factoring to find out the unknown value while utilizing the box method. So that's what we're going to do, guys. So let's go ahead and read the problem. It says, Mr. Sands surveyed 50 students to record their favorite ice cream flavor. Each student chose one flavor. Based on the results shown in the circle graph below, which is this, how many of Mr. Sands' students chose chocolate as their favorite ice cream flavor? Okay, so let me reread the question again. It's asking how many students chose chocolate as their favorite ice cream flavor. Okay, that's what we need to find out, guys. We're trying to find out how many students chose chocolate as their favorite ice cream flavor. Okay, now remember, guys, dealing with percents, there are three different important parts dealing with percents, right? You have the whole, which is the total amount of participants, or the total amount of whatever we're talking about. We have the part, which is part of the total, and then we have the percentage that represents the part, okay? So what was the total number of students that did the survey, right? There were 50 total students that participated in this survey, okay? So let me go ahead and put that, guys. That's gonna be our whole, right? That's gonna be the whole, or the total. Okay, so the whole is 50 students, okay? Now, let's read the question again, guys. They wanna know, or Mr. Sands wanna know, how many students chose chocolate as their favorite ice cream flavor, right? So if chocolate is the specific subject that we're focusing on, chocolate is gonna represent the part and the percent, okay? So let's go ahead and put that. We have the part, we have the percent, and they both represent how many students chose chocolate as their favorite ice cream flavor, okay? Okay, now, in this particular case, guys, they didn't give us the exact number of students that chose chocolate. We're gonna have to solve for that. But they did give us the percent of students that chose chocolate, right? And we can actually find that out by utilizing this pie graph, right? Or this circle graph. I usually call it a circle graph or a pie graph, right? Either or is the same, okay? Now, I just wanna go ahead and jot these percentages down, okay, just real quick so I can see what we have, okay? It says that only 14% of the students chose coffee flavor as their favorite flavor, right? 14%. Okay, vanilla, 26% of the students chose vanilla as their favorite flavor. Okay, strawberry was 18%. Okay, and then as you can see, guys, the last flavor we have is chocolate, but in this problem, they didn't give us the percentage of the chocolate, right? They didn't actually just give us the percentage, but based on the knowledge of us knowing that a whole pie graph represents 100%, what we can do is we can add up these percentages in order for us to find out what is the percentage that represents chocolate. So we're gonna add up these three percentages, and then we're gonna subtract them from 100 to find out what was the percentage that represents the students that chose chocolate, okay? So let's go ahead and do that. I'm gonna add those up. Okay, 4 plus 6 is 10, plus 8 is 18. I'm gonna carry the 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 1 is 5. Okay, so 58%. And then I must subtract this from 100 in order for me to find out the percentage of students that chose chocolate, okay? All right, 100 minus 58 is 42. 42. Okay, so for the chocolate, guys, I know that 42% of the students chose chocolate as their favorite ice cream flavor, okay? 42% chose chocolate because, once again, 14 plus 26 plus 18 plus 42 will equal 100, okay? So chocolate is 42%, okay? We know that, right? So we have the whole. We know that there were 50 total students. We have the percentage that represents how many students chose chocolate. Now, based off the percentage and the whole, we can find out the exact number of students that chose chocolate, the actual quantity of students that chose chocolate, okay? So all we need to do, guys, is just plug in these values into this box method, okay? And because we're finding out the part or the actual amount that chose chocolate, we're gonna put it as X, right? The unknown value, we're gonna put it as X. So let's go ahead and draw this box method real quick, okay? Let's draw a box divided into 4 smaller boxes. All right, remember, guys, the bottom row always represents the total, okay? 100% is the total percent, and the whole, right, is 50, right? There were 50 total students that participated in this survey, okay? And the top row is the subject line, right? Which is chocolate. How many students chose chocolate? So I'm gonna write chocolate, okay? The percent was 42% chose chocolate. But remember, guys, we're trying to find out the part, the actual quantity, how many actually chose chocolate, right? So that's what we're gonna do, guys. So what we can do is we're gonna cross multiply and then we're gonna solve for X, right? Or what we can do is, guys, we can actually look at the scale factor. And what I'm gonna do is, guys, in this particular example, I'm just gonna go ahead and do scale factoring because I wanna show y'all, guys. So I'm gonna do the second method, which is scale factoring, okay? And it's very, very simple, guys. It's very, very simple. Now, scale factoring is when a number is a multiple of another number, okay? When a number is a multiple of another number. So for example, 6 is a multiple of 2 because 2 times 3 is 6, right? 12 is a multiple of 2 because 2 times 6 is 12, right? So those numbers are multiples of 2 because as I keep counting by 2, I'm going to eventually become those numbers, right? So either we can scale factor vertically or we can scale factor horizontally, depending on what numbers are multiples of one another. So the first thing I want to do, guys, is identify what X is. X is at the top right corner. So either we can scale factor horizontally or we can scale factor vertically, okay? I'm going to scale factor horizontally because 100 is a scale factor of 50, right? 100 is a scale factor of 50. 50 times 2 is 100. So if I know 50 times 2 is 100, then I know that 100 divided by 2 is 50. So going forward, guys, I'm going to divide by 2. I'm going to divide by 2. Okay, and dividing by 2 is the same thing as multiplying by 1/2, okay? Dividing by 2 is the same thing as multiplying by 1/2, okay? So I'm going to divide by 2. So 100 divided by 2 equals 50. If I divide it by 2 down here, then up here, I must divide 42 by 2 to get X. So let's go ahead and do that, guys. 42 divided by 2. 2 can go inside of 4 twice. 2 times 2 is 4. Subtract, I have a remainder of 0. 2 can go into itself 1 time, right? So the value of x is 21 because 42 divided by 2 or 42 times 1/2 is 21, okay? So if x equals 21, it's safe to say that 21 students chose chocolate as their favorite ice cream flavor, okay? So x equals the 21 students that chose chocolate. Okay? That is our final answer, guys. Okay? That is our final answer. Okay? 21 students chose chocolate. And also, guys, if we would have did it the opposite way, where we would have cross multiplied, x would have still came out to be 21 students. Okay? So thank y'all so much, guys, for tuning in. Please be looking forward for more examples. Thank you.